Big pillar, Rachel.
So factoring. Cool. Hey, I'm going to put some notes up here in the corner that I want you to follow. But on your paper, go ahead and write down the notes as well. This chapter we'll use factoring a bit. We're doing a review because it's not reviewed in the chapter much. And then when you get to chapter 4, we actually expand on it and do some more complex factoring. So kind of like factoring on steroids. Okay? So those of you that were at the Summer Math Academy, that'll help you out quite a bit today. I will show kind of a bit of a different spin in terms of the factoring on it. So if you would please follow the guidelines I give today, and then you can choose if you have another method that works really well for you, you can do that as well. But at least follow along with me today because it may help you out. You might find a quicker way or something you like better. Okay. So the first thing when you're factoring, actually tell your neighbors real quick what you know about factoring. What's it mean you have to do it? All right, so since you're back up here, so what are some of the things you know about factoring? Yeah. Okay, so good. Actually, the first step we do is we're going to multiply A by C. Okay, now in order to multiply A by C, you actually have to know what A and C mean. Hey. Yeah. You sure can. Not sure where, but we will find a spot. Why don't could you just pull a chair, grab that chair and maybe sit by Derek there. Derek, you'll share your table, right? That's how especially special. Or if you have, you could grab a book or you can write at the edge, Tyler, or you can use this stool as a table. Okay? So in order to understand how to multiply A and C, you actually have to know what A and C are. Okay? So using this form, A, B, and C, notice that the A is connected to the x squared, it's the coefficient, B is connected to x, and C doesn't have any variable by it. Okay? So if I'm going to actually work through number 1 as we're doing this. So if I'm multiplying A by C here is, A is 3, I'm not going to write these out every time, B is 5, and C is 2. Now if you didn't know that, if you're like, well, isn't A 3x squared? No, it's not. We don't include the x squared. Okay, it's just 3. Okay, B is 5, C is 2. So we go A by C. A by C is 3 times 2 or 6. Okay, and after we have that A by C, what we're going to do here, and this is where I put a bit of a different spin than like me and Vogel showed this summer, is I'm going to have you do this kind of diamond type thing. Now some of you have seen this because your Algebra 1 teacher may have had you do it, but some of you are going to be like, I don't do that. So I don't think I want to do that. I want you to do that, at least for a couple problems. And you can decide if you don't want to do it. Okay, so A by C, if you're putting your notes, your A by C is going to go up there. So if I'm got that X on this one, I'm going to just go like that. Okay, and what I'm going to put down here is my B term. My B term is 5. Now why would I do that? Those of you know anything about factoring, how is that helpful to me? Emma? Good. The things you multiply to get 6, the A by C, have to add to 5. So what you want to do for step 3, and if you're writing this out, and I know, like I said, I hope you're writing this on a separate sheet, but step 3 is find the factors of A times C that add to B. That add up to B. Okay? So factors just mean, if you're like, I don't even know what factor is. Factor are things that multiply to make something. Okay? So A by C that add to B. All right. So 2 things that multiply to 6 and add to 5. Okay? And before you guys, I realize many of you know it, but before you start like just randomly picking out numbers, because it's not as always easy as 6, like start going in order. Like start with 1. Does 1 times 6 add to 5? 1 and 6 add to 5? No, it subtracts, but doesn't add. Okay? How about 2? 2 times 3. 2 times 3 add to 5? Yeah, and it multiplies 6, so we put the 2 and 3 here.
No matter what one you put it in?
Doesn't matter what order. I will generally put the smaller over here because I'm type A like that. That's just me. Sorry. Okay? 2 by 3. All right? So, like if you want a kind of a picture for the number 3 over here, really you're just filling in these spots. Okay? So now you have that kind of visual. All right? Some people call this the diamond method. I don't know. Different shapes. Okay. The next step, number 4, is you're going to set up your quantities. Now, if you recall our quantities, last chapter we called this what number or letter? No, P, and this one? Q, okay? Now, remember, it doesn't have to be minus, minus. It could be plus, minus. It could be plus, plus. It could be minus, plus, okay? The next step is to set up your quantities. How do you do that? Well, you just go over here and you say, well, I just found my number, so I'm going to do x, because it's x, and I'm going to say positive 2, and I'm going to say positive 3 in the other one. Why? Because those are both positive. So x plus 2, x plus 3. And they would be great if we were done there, but if you check your work, x times x is x squared, not 3x squared. Automatically, you know you're not done, because that's not right. You're like, well, just put some like a 3 in front. I'm good. Well, nope, that's not how it works. Okay? So we got to do another step here. The next step, step 5, is to divide P and Q by A. Divide P and Q by A. So if you want to think of it in terms of your picture, this is where you're at right now. You have x minus P. Well, you're going to divide by A. And you have x minus Q. Well, you're going to divide it by A. Okay, and I'm actually going to show the next step because it kind of goes hand in hand. You simplify. Which a lot of times we call that reduce in this case. We reduce those fractions, that P over A and Q over A. Okay? And so if I'm doing that, and this I'm dividing by 3, and here I'm dividing by 3. Now, can I reduce 2/3? No. Can I reduce 3/3? Yeah. Now some of you go, well, 2/3 is like 0.66667. Okay? Okay, 0.6 repeating. And we're not going to do that. Right? So what do? Oh, you're getting ahead of the game. Let's just reduce. Let's make that 1. Okay? And then Derek's actually telling us the next step. Go ahead, Derek. Good. And once you're done, once you've finished reducing, if there's anything left on the bottom, you move it out in front. There. So there's nothing left on the bottom here. There's nothing to move. But here there's a 3. So it becomes, unbelievable. See the time I use pen. 3x plus 2 and x plus 1. Okay? So step 7 is to move the remaining denominators if you're like, I don't know what a denominator is, make a note, it's the bottom number, to the front of your quantity. And if you have to, give yourself an example. Like number 1's a great example for what you've done there. Those are the steps we take. Now, they'll go a lot faster. Right now, we're just working through, okay, one together. But from here, just double check your work. All right? Let me give you a second to copy that, actually. You guys, once you're done factoring, double check it. It should go, it's as fast as FOIL. This is where I actually kind of use FOIL because it's a binomial times a binomial. I say my first times my first, that's 3x squared. My outers, 3x and 1 is, that's 3x, right? My inners, 2x is, 5x, good. 3x and 2x is 5x. And then my last, 2 and 1 is 2. Double check it real quick. Okay? I even sometimes do it faster. I just say the front times the front is 3x squared and the back times the back is 2. So I'm good with those two, and then if I want, I can do the inner and the outer. Okay? That's it. We're done. All right. Any questions? Here's what I want you to do, and follow along with me. I promise it'll make this a lot easier. Right now, I want everyone to do step 1 and step 2 only. Step 1 and step 2 only for the first column. Columns go this way. So 4, 7, 10, 13, 16, 19. Step 1 and step 2. So all you should have for like number 4 is 2 times 10 is 20. And then my B term is 9. That's it. I don't want you to do anything else. Then move on to the next one. Okay? Make sure you note that on number 7, that B term is negative. As well on number 10. Then on number 13, make sure you know A times C is negative. As well on 16. And then on number 19, they are both negative. Okay, how many got them? Difficult?
No.
Not so much. Okay, so now I want everyone to do step 3. Find the factors that add to A times C and multiply, or excuse me, that multiply to A times C and add to B. Okay. Okay. Hey, I realize most of you aren't done yet, but just so as you're going through this and you're trying these problems, you're like, okay, 2 things that multiply to make 20. Don't go random, okay? Like start with 1 and then try 2 and then try 3. You have to go all the way to 20. 1 times 20 doesn't work. 2 times 10 doesn't work. 3 times doesn't even go into it. 4 times 5, well, that multiplies 20 and that adds to 9. So 4 and 5. Be orderly about the way you're testing them. Don't go random abstract on it, okay? 1 times 10. That work? 1 times 10 doesn't work on number 7, but what does? Yeah, negative 1 times negative 10. 2 negatives multiply to make a positive. Okay, how about 63? 2 things that multiply to make 63 and add to negative 24? Negative 3, negative 21. Okay. 2 things that multiply to make negative 35, add to 2. Negative 5. Positive 7? Yeah. Negative times a positive is a negative. There are more positives than negatives, so when we add them together, you're going to get positives on the output. 2 things that multiply to make negative 24 and add to 10. Positive or negative? Negative 2, 12. Okay? And here, good. We're good? All right? You guys, I really appreciate it. I realize some of you do other methods. Okay, you've learned other ways. How many of you have learned this a different way than I'm showing? Okay, you guys, please, hey, I'm asking you to please try it this way right now. So if you're out there right now and you don't have any of this on your paper and you're doing it your own cool guy way, okay, that's fine for later. Try it this way right now, please. Okay? Right now, I want you to go ahead and set up your quantities. All right, quantity here. Notice they're Y's. So you're like, what? I put X. Dude, they're Y's. Oh, man. This one's P. Unbelievable. I thought about telling you guys ahead of time, but I just want to see if you'd figure it out. I know sometimes you guys like me to wait until the end to tell you.
Oh, yeah. Definitely. Totally. So that way we can do extra work.
Well, at least you got that one. That's good. Unbelievable.
So did I, Faith. So did I.
All right.
And then you're going to tell us that the variables doesn't.
Yeah. Well, okay, next, I want you to divide them all by A. Okay, go ahead and do step 5 and step 6. Divide by A and reduce. Simplify it there. These are so easy. They all they reduce nicely, the ones that reduce. This one becomes a 2. So we get y plus 2. This 2 just jumps out in front because it doesn't reduce. So 2y plus 5. Okay, how many of them done? You guys checking them? How can we double check again to make sure we did them right? Distribute, FOIL, multiply them out, right? Just double check. X times 5x, 5x squared, 1 times 7, negative 7. And then that's 5x, and that's negative 7x, which gives me negative 2x. Okay. Hey guys, what I want to point out here, as we work through all of these, did the process change? No, it didn't matter what form you were in, whether it was minus bx minus c, or plus bx minus c, minus bx plus c, or plus bx plus c. They were all the same. The steps were exactly the same. It organizes your thoughts. The goal when factoring is for you to become efficient. It should not take you a long time. So like those of you, how many of you learned the box method? The box method's a nice way to do it, where you put your little area model method. That's great if you can do it efficiently. The problem that some students have that do it with they have their box and they do all that stuff. The problem with that, it's a great way to introduce it. The problem with it is it becomes a very inefficient method if you can't move past drawing out the box every time and pulling things out, and you're sitting there dwelling in your brain and then there becomes a lot of inefficiency to it unless you can make it efficient. It doesn't mean I don't want you to do it that way. It means I want whatever method you choose to do to be an efficient method. It means you can do it quickly. Okay? So, I have a couple more things, just really quick. This problem right here, x squared plus 5x plus 6. Those types of problems right there, you should not have to use a diamond for. Why? Because it's missing one specific term. It's missing a. That means a is not 0. It's 1. Which means, really, if you were to make your little x out of it, it'd be 1 by 6, which is 6, and you're adding to 5. Well, 6 and 5 are right there. You just say, hey, two things that multiply to make 6 and add to 5 are?
3 and 3.
2 and 3, not 1 and 6. Okay, 2 and 3. X plus 2, x plus 3, I am done. I don't have to divide by a. Why? Because a is 1. If I divide by 1, I just get the same thing. Okay, so when you see a problem with a as 1, you're like, woohoo, dude, factoring's a piece of cake. Okay, so if I give you like x squared plus 12x plus, I want you to come up with a number that's going to allow you to factor that perfectly. Figure it out. Punk, he yelled it out. 7, so no one else will think now. Is that right, though? Is it right?
No, because you have to.
It's backwards, right? Oh, man. But Chase, you can still be a punk if that makes you feel any better. Okay? There we go. Find a number that will work. All right. Let's see.
I got the best one.
Let's get some numbers. Which one? What's one? 36. Okay? So you're saying 6 times 6 makes... So that would become x plus 6, x plus 6. Yes?
Yeah.
Okay. What's another number that would work? Yeah. 11.
You stole my Tyler.
Oh, Tyler stole it. So that would be, if it was 11, we would have x times, or x plus 11 and x plus 1. Now, just so that everyone's not confused, these are not the same inequality, or expressions, right? That is that. This one is that. They're two different things. Okay? What's another one? 20. X plus 2 and x plus 10. Okay? So x squared plus 12x plus 20. Okay? Those should go really fast, right? If a is 1. Everyone with me? What happens if it doesn't factor? Like when Chase gave us the 7 there. Okay? That was good, man. He's thinking teacher-wise. That doesn't factor. What do we call that? Yeah, that's called prime. We also say it's no solution when we have it in a graphic form. Prime. No relation to Optimus. Okay? Yeah. All right. One last thing before you get to do your assignment. You guys ready for it? It'll be amazing fun. Number 5.
Whoa.
Yeah.
Look at that.
Number 5. Get as far as you can, please. So here is what I generally think students get to. Now, I could be wrong. You could be amazingly awesome at it. Most of you will go 12 times 5 is 60, and you'll find two things that multiply to 60 and add to 19 pretty fast.
Yeah.
You say it's 4 and 15. How many made it that far? You're like, this was a piece of cake. Like, why even bother us with such a trivial problem, McCoy? Okay, well, what ends up happening here is you divide by a, and then you're like, oh yeah, that's 12, and that's 12, and you're like, all right, man, nothing reduces. Or, excuse me, nothing cancels out. So, is it just like 12z plus 4 and 12z plus 5 or 15? Yeah, you've got to reduce first. Now, I'm just playing I'm playing factoring like, or the person who doesn't know how to factor really well, or they don't check their work, because that's 144z squared. Right? And the back is 60. Okay? So this does not work. You've got to reduce first. So everyone talking, be done talking. We're done here in a minute. This becomes a 1, and this becomes a 3. This becomes a 5, and this becomes a 4. Now, if you forgot how to reduce, you're trying to find the number that goes into bold, right? Okay? You divide each term by it. So, in this one, this comes up here, and that becomes 3z plus 1. And this part goes over here, and that becomes 4z plus 5. And then when you check your work, 3z times 4z is 12z squared. 1 times 5 is 5. That's 12z, and that's 5z to give us 19z. Oh, that's not right. 15z, okay, and 4z, 19z. All right. How many got it? So maybe I shouldn't have even bothered you with such a trivial problem. Unbelievable. All right. Very good. Your assignment is the back. The front is extra credit, the rest of the front.